Hi everyone, Mrs. Reynolds here, and this is a video about getting started with your create task for the AP Computer Science Principles exam. So as you already know, the Computer Science Principles exam consists of three parts. You have a create task, which is where you're creating your own program and then writing about it. You have an explore task where you're basically writing roughly a 4 to 5 paragraph research essay where you're citing sources. And then the last part of the AP exam is a 74 question multiple choice exam. And I have recommended to go on Amazon for $11 and get that book, Crash Course for AP Computer Science Principles. It's a fantastic review course. Also, jump on code HS. If your teacher has given you a code, there is a great practice exam on code HS. I've given it to my students. So that is basically the gist of the AP exam. So this video today is to get you started for writing your create task. And I am going to throw a title on this video, and this is called Before You Create Your Program. So it's before you create your program. We're going to go through a checklist. All the links will be provided for you underneath the video. You're going to be able to click on the document that I go over today with you, and you're going to be able to click on the link to the AP College Board website, and you'll be able to click on an actual create task. Okay, so first of all, there are tools that you have access to, tools that you need before you start creating your create task. The first very important tool is the College Board website. I will put the link, like I said, below the video, but if you just Google AP Computer Science Principles College Board, you will be directed to this link, and what this has is everything you need to know about the create task. Actually, everything you need to know about the performance tasks, so both the create and the explore task. So I would strongly encourage looking through this entire website here. They give, the best part about this website is they give examples of already graded create and explore tasks and what the judges or scorers have scored each example. They give score commentary. All these links are fantastic. These examples consist of different programming language. So there's a Python example, there's maybe a Scratch example, there may be an App Inventor example. So this is really a fantastic resource. The second resource that is truly fantastic is the scoring guide. This is your rubric. This is what the judges are looking for when they are scoring your create task. If you notice, the rubric has rows. So there's row 1, 2, 3, 4, 5, 6, 7, and 8. Now, luckily, you have me, Mrs. Computer Science, and what I have done for you is I have unpacked this entire rubric so that it is very easy to understand. Because what I have found is last year, the rubric was made available to students, but instead of looking at the rubric before they created their program, they looked at the rubric before they did their write-up for their program. So what happens usually when you do that is you create an entire program, an entire computer program, and then when you go back to look at the rubric and get ready to write everything up, you notice that you have forgotten certain mandatory items that were listed in the rubric because you were so excited creating your program. You might have created a video game, you might have created an app, you might have created a cool program in Python that calculates angles for elementary school students. Who knows? But students get so excited creating their programs that they forget to look at the rubric until they're ready to start the write-up for their programs. So I have unpacked this for you. What I want you to notice about this rubric is you either get a 1 or a 0. I guess the scorers want to be funny and relate to binary numbers. But you either get a 1, meaning yes, they have done what we asked them to do, or a 0, they have left out one or all parts or two parts of what we asked them to do. So in row 1, you are either going to get a 1 or a 0. In row 2, a 1 or a 0. In row 3, a 1 or a 0. So it's either a yay or nay. It's all or nothing. Okay, row 1, we are not going to talk about row 1 in this video. What row 1 means is after you have created your program, whether it be an app, a game, a program, whatever, you are responsible for creating a 1 minute or less video demonstration of your program. Why do you think we need this? Why do you think you are asked to create a 1 minute or less video of your program? Obviously, it's so that the scorer can see how your program runs. Because if not, you could write a nice essay about your program, and who knows if it really is a working program? Who knows if your code is truly correct unless it's actually executing properly? So this is a 1 minute or less video, and you have a choice with this video. You may either be a narrator in the video and talk about what is going on in your program while the video is playing, or you may have a completely sound-free silent video of your program executing and then write a paragraph explaining what is happening in the video. Okay? So that is for later. Do not worry about anything having to do with a video right now. That step will come afterwards. So this is the guide for creating your program. This is what you're going to do before you even create your program. Let me remind you that you can use any programming language you wish to use. You may use Python, you may use App Inventor, Java, JavaScript, Scratch, anything that you would like. Even if you have learned Python throughout your entire AP Computer Science Principles course, you are allowed to use whatever programming language you would like. The second thing I would like to make sure you understand is it is up to you what kind of program you choose to create. You may use App Inventor to create an app for Android. You may use Python to create a program. You may use Scratch to create your own video game. You may use Python with Pygame to create a video game. So it's completely up to you. So the first question you're going to ask yourself is the programming language I have chosen the easiest for me to complete this task? The second question you're going to ask yourself is my program unique? This means make sure that you are not straight up copying code line by line somebody else's program, because that is indeed plagiarism. It is fine to get ideas from other programs and tweak the programs and make them your own, but they truly have to be your own spin off of the program. If you're creating, let's say, a Rubik's Cube generator that has been done many times before, you want to make sure that it has your own special, unique tweak to the program. The third question, am I sure I will not need to get help from anyone? You do realize, or I hope you realize, that once you start your create task, your teacher is not allowed to help you with your program, and you should not be getting help from anyone else. Remember that this is an AP, Advanced Placement College Board exam, and it is as if you were doing this alone. You do have the option to choose a programming partner. I am a virtual teacher, therefore my students do not choose the option to have a partner, but you may choose to have a programming partner in your class. But the write-up on that is a little bit different because there are certain things you have to do where you're mentioning what you have done as opposed to what your partner has contributed. And I will not be reviewing that part of the write-up in my videos. I am only providing the videos where you're going to be working alone. So you want to make sure that you do not need help from anyone. If you've answered yes to all these three questions, you are ready to start. So what you need to think about is you want to design a program with the following in mind. You want the program to make some sort of sense. You don't want a program that is not going to work or that is going to be difficult for the judges to understand. You want the program to include one algorithm with at least two other sub-algorithms within that function independently. So remember, your algorithm includes either sequence, selection, or iteration. Then you need at least one of your algorithms to contain mathematical or logical concepts. Either, I'll give you an example, this may be a game that you have created where the mathematical concept is that a score is added up every time the player achieves a certain status. Maybe the score increases. That takes a mathematical concept, or you're using Boolean logic. Also, the program contains at least one example of a student-created abstraction, either a procedure or a data set that also incorporates either math or logic. Okay, so please note that simply setting a variable to true or false does not count as logic. Okay, and I'm going to give you some examples. So examples of algorithms with two or more nested algorithms, including math or logic. So in Python, here's an example, and you have basically a function which draws a card of values 1 to 14. Okay, the mathematical concept here is that it's using the random class, and it basically appends it to the player's hand. You see that there are nested algorithms within the algorithm, the main algorithm. So you have a loop. We have a while loop here. That's iteration, and then selection. You have your if-else statements, elif statements. There's an elif statement in here that interprets the player's decision. So it goes through the loop. If the player hits it again, it starts it over again. And then there's a final score, which is calculated by the score function. Okay, so there's lots of math in here, and obviously the algorithm is evident as well. There are sub-algorithms within the main algorithm, and you can see iteration and selection. So that is a really perfect example, and this again will be provided in the link under the video. Here's one in App Inventor. This has a function here, draw square, and it has some parameters, X, Y, size, and fill color. Then you have an initialize a local variable. You have math blocks right here. You have the plus here. That counts as math, even though it's just a plus sign. Don't get discouraged and think it has to be any kind of fancy math. They said to use math, so math is math, even if it's +1, even if it's every time your video game character gets hit on the head with something, it's a -1. That is still considered math and it will be accepted. You have an if-then statement here, which is a conditional. So you have selection here, and there's more math over here, +1, +1, -1, -1. So you can start to see what they're looking for here. This is not a very good example, okay? First of all, when the flag is clicked is what I had mentioned before when I said a student created abstraction. So this does not include abstractions or functions that are already set within the program. They're called event handlers. So when the flag is clicked, that really does not count. This could count as an algorithm, but you really cannot write about how these algorithms function independently. You can obviously talk about how they function together, but not independently. Compare that to something like this, where you have functions that are being called. Called fill square, that functions, you can take this out and it is functioning separately. The call stroke square functions separately. As a whole, works together with all of the embedded algorithms here. But if you look down here, you really are not going to be able to write too much about how they function separately. So that's not a very good example. So here are some examples of student-created abstractions. So in Python, you have you're defining your own function. So this is a student-created function. You have sum here, so you're defining a function called sum. The parameter is hand. Basically, the sum function goes through each card and it basically converts into a number value. And then you see the math here. And this is actually a really, really great example because it includes mathematical and logical concepts. Even though you only have to choose one or the other, this one actually has both. A sum variable is declared and set to 0, and then the loop is run through the hand. The if, elif, else statements, they determine the value of the cards, and then they add it to the sum. In a nutshell, okay? And just last year, since I was an AP Reader Rater, I was a scorer for the AP exam for the Create tasks, we were told that just last year, when I start as a clone in Scratch, if you're familiar with the Scratch program, this now counts as a student-made abstraction. Even though it's part of the Scratch program, and it's kind of like an event handler, we were told last year that this does count. It is now acceptable as a student-created function. Then the last part of this video, we're going to go over, so you've created your program, now what? So, you have created this fantastic program. Maybe it's an app that helps you navigate through your neighborhood. Maybe it's an app where seniors are assisting new freshmen so that they do not get bullied in school. Maybe it is a video game created with Pygame, like the old game that I used to play in the 1980s called Simon, where you have to match what music notes are played. Maybe this is a video game created in Scratch. Whatever program you have created, now what? You're going to print this chart out and you're going to make sure that your program meets the following criteria. Everything should get a check of a yes. If you notice that you are checking the no box, you need to go back and revamp your program before you even think about completing the write-up portion. Okay, number 1, your video. You are going to come back to this one later. I'm going to provide more about this in the next video. This cannot be completed until you make sure your program is ready to go, that it achieves all the checks over here in the yes category, in the yes department over here, and you are going to make sure that your program functions properly. So we're going to skip number 1. We're going to go ahead on to number 2. Number 2, I will be able to write about my development process, including phrases such as, through the testing of my program, I noticed that, I revised my program by, upon revising my program, I was able to. You should be able to complete these phrases. The scorers do not care whether you chose pink or blue background color, or whether you decided to throw a title page onto your app, or that your app started with 2 pages and ended with 4, or that you started with 4 lines of code and you ended with 400 lines of code. They only want to know programming details, your strengths and your weaknesses of your program, and how you developed a plan to fix those problems, and what was the result. Number 3, I will be able to write about at least 2 programming difficulties or 2 programming opportunities which arose during creation. I will then be able to write about how these 2 identified difficulties or opportunities were resolved or built upon. Again, the scorers do not care whether you choose pink or blue background. Again, they only want to know about programming opportunities or programming difficulties. If you choose to write about difficulties, how did you solve them? Both difficulties. How did you solve both difficulties? Or if you came across programming opportunities, what happened as a result of that? 4. You have to understand. I know how to use a program such as Google Draw or Microsoft Word to digitally draw an oval around the specific algorithm in my code. If you do not know how to do this, check out my other video in my channel. It will walk you through how to use Google Draw to put an oval around your algorithm in your code. Number 5. I will be able to write about exactly how my algorithm functions, not just what it does. I will be able to write about how my algorithm incorporates math and or logic. And I have highlighted here, see notes on math logic at the bottom of this document. So we'll go over that in a minute. Another thing you have to do for criteria number 5 is I will be able to explain the purpose of this algorithm in relation to my entire program's purpose. That is very important. A lot of students do not gain that point, that 1 point, and it stays as a 0 because they do all of this. They have an algorithm, they have their sub-algorithms, they include mathematical or logical concepts, but they forget to write about how their algorithm functions in relation to the purpose of their entire program. That's very important. 6, I will be able to write about how the 2 or more sub-algorithms function independently. I will be able to write about how my entire algorithm, all parts, function as a whole. 7 is the same exact thing as number 4, only instead of knowing how to use Google Draw to draw an oval around your specific algorithm in your code, you need to understand how to use Google Draw to draw a rectangle around your specific abstraction in your code. And again, that is in my video as well. And number 8, I know that my abstraction was created by me and not something already in a program such as event handlers or control structures like when flag clicked. I will be able to write at least one sentence about how my abstraction contains math or logic using something similar to this sentence starter. This abstraction uses math by, or this abstraction uses logic by. I will be able to write how my abstraction manages the complexity of the program using something similar to this exact sentence starter. This abstraction helps to manage the complexity of my program by, and then you would continue to write. Now, if you have checked yes for all of these boxes, then you are ready to complete your official write-up of your program. I had mentioned earlier that I was going to put on the bottom of this document some notes on math and logic. So what I did was I just copied these directly from the rubric on the College Board site. So this is listed for you in the document as well. Mathematical concepts include expressions using arithmetic operators and mathematical functions. Logical concepts include Boolean algebra and compound expressions. And then there's a little bit of information on iteration and selection. I hope you've enjoyed this video on what to do before you create. And stay tuned for the next video, which will walk you through the writing process on how to complete the write-up portion of your create task. Good luck and have fun creating your programs.